The conditional operators give us the opportunity to decide about running a command based on whether or not a previous command succeeded or failed. But it's a very simple mechanism designed for simple tests with one command to run if it succeeds, one command to run if it fails. Quite often we need to do something more sophisticated, either with the actions we're taking, the commands we're running, or with the tests themselves. We have seen how to use the test command with a conditional expression, but it is actually more commonly combined with other commands that allow for more sophisticated actions to be taken. To look at these things, let's also revisit our test command. Recall that the test command allows us to specify a test expression. It evaluates the expression and sets its exit status based on whether the expression came out as true or false. If the expression says, check if a directory exists and gives a directory name, well, if it's true that the directory exists, the test command will exit successfully. If the directory doesn't exist, it will exit unsuccessfully, and we can use that in our commands to decide whether or not to run a second command or not. Test is one name for that command. There's another name for the exact same command. The left square bracket is actually a command. It's an alias for the test command. The difference being, if we run test with the word test, the letters T-E-S-T, the remainder of that command line is the actual test expression. On the other hand, if we run test using the square bracket, everything else until it sees a right square bracket is considered to be the test expression. Makes it easier to visually see where the start and end of the test command is. So if I were to run the command test-d/etc to evaluate whether that's there or not, that's exactly the same thing as typing left square bracket, which is test-d/etc, which is my expression, and it ends when I put a right square bracket. Please note there's a space after the left square bracket, because otherwise it would see the square bracket -d as the command name, which of course doesn't exist. And there's a space before the square bracket at the end, otherwise it would consider that bracket to be part of the data for the test expression. These two are the exact same test. Inside the square brackets, we can do any test expression that we would do with the regular test command. A new function that we're going to introduce on this slide is the ability to combine expressions. If I would have done a test if the directory etc exists, and if that is true, if that succeeds, also test if I can read /etc with a different expression, and if that is also true, go do something, I could combine those two into a single test by putting -a between them. -a is and. So then this would be if the directory etc exists and /etc is readable. Now the test will be true and it will exit successfully. If it wasn't a directory, or even if it was but I couldn't read it, this test would be false and the test would exit unsuccessfully. You can also use -o, which means if either side of the expression is true, the output is true. The next thing that's good to know is the different test expressions we can use, regardless of whether or not we combine them with other ones. There are two general types of testing that we do. We either test files or we test data. When testing files, here is a list of common file tests you may wish to do. They are all listed here in detail. They're also listed in more detail on the Bash manual page, and there are additional tests available besides these for files which aren't on the slide. These are the ones most commonly used. Does a name exist in the file system as anything? Is a file name in existence and is a regular file that holds data of any kind? Or does the file name exist and it is a directory? Can we read the file? Can we write a file? Does a file name exist, but it's actually a symbolic link, a shortcut to another file? And the -s test, does it have a size? If the size of a file is 0 and there's no data in it, this test is false. If there is anything in the file at all, this test is true. Any of these tests can be changed from true to false by putting an exclamation mark in front of the test operator. So, in my example, if I were testing if the directory etc exists, if I instead wanted to test if it does not exist, I would put an exclamation mark in front of my test. Now it's testing if it does not exist. If it does not exist, the test will be true. You can do this with any test operator. The test operator is the part of the expression that tells the test command what kind of test it is. In our case, the -d. In the other one that we saw a moment ago, there was also a -r. That was also an operator. In the examples on the slide, the -e, -f, -d, -r, -w, -h, -s, these are all operators for testing. All of these operators are testing attributes of a file. Note that none of them test the content. They're only testing attributes. When we test for data, there's two kinds of tests we might wish to do on our data. One kind of test is, does the data exist or not? And the other type of test is comparing it to some other data, typically a known value, to see if that data has a particular value. We may also compare things to see which one is larger, smaller, newer, older, whatever. These two kinds of tests are known as unary and binary tests. A unary test tests one thing, normally some characteristic or attribute of the thing you're testing. If I want to check if I can read /etc, I'm testing an attribute of the etc directory or file, whichever the case may be. I'm testing one thing. A binary test is one that compares two things. These two have a different way of being written. When testing one thing, the expression goes operator thing to test, whatever the operator is. When we test two things, we're comparing them. So we have the first thing, the operator, and the second thing, whatever that happens to be. So the operator goes between the two things being compared for a binary test. We can use the exclamation mark with binary tests just like we use it with unary tests. It's important to know which one of these is which, because if you're using variables when doing your testing and your variable has nothing in it, you have to be careful of substitution. If I had a test to see if $variable2 had a value that was greater than variables3's contents, this would work fine if variable2 and 3 both have data in them. But what happens if variable2 is empty? Or if variable3 doesn't exist? Substitution will cause the variable that's empty or doesn't exist to simply be removed from the line before the test command runs. Remember that the square bracket is just the test command. If that happens and you get a situation like we're showing on the screen now, you'll get an error saying that GT is not a valid unary test, or that the binary test operator GT expects two things to operate on. That's what those errors mean. They are very common. You're very likely to run into them. The unary operators that work on data can either work on text or can work on a variable name. We can check if a variable exists with -v and the variable name. If I were to do test -v myvar, this test is true if the myvar variable exists, whether or not it has any data in it. If the variable does not exist, this is a false test. Myvar in this case must be the name of a variable. For string tests, there's -z and -n, and normally you test the content of a variable or the output of a command, which may have already been stored in a variable. If I were to do -z $myvar, this is a test to see if there is no text, no data here. Remember that substitution gets rid of the dollar and variable name and replaces it with the actual content. So if my substitution would make it go away with nothing to replace it, and you're going to get this error that a unary test expects some data to work on. The way we solve this is we put quotes around the possible data. If $myvar has data in it, say the word red, substitution will replace $myvar with red and run the test. It isn't zero length, it isn't empty, so this test will fail. Myvar variable had nothing in it, was empty. It existed but had nothing in it, or didn't exist at all. When substitution removes that, we still have the empty quotes. And now the -z test will see, aha, there is something there, but it's got no data. It's empty. And this test will succeed. So put quotes around your variables when using them in tests. The -n is the opposite of -z. Is there any data here? If there is, this test is true. -z means, is there no data here? In which case it would be a true test. We wouldn't normally do any of these tests, the z or n, on literal text. I wouldn't have a command like -z and literally hello world. That test will never be true because there is always data there, so we would never actually use it that way. The other kind of test that you can do on text